We need to build a backend for a real estate agency, including a web section and another section for smart devices, all of which will be used by the agents in their mobile work. For this purpose, we create a KB, the property transaction to record the real estate properties for sale or for lease, and the neighborhood transaction to keep a record of the neighborhoods. We have also defined that the web backend will be generated in Ruby in the cloud. To implement the smart device section, we will apply the work with pattern for smart devices to the property transaction, to the neighborhood transaction, and create a dashboard object as an entry point. From the start, we have decided to generate only in Android, the default platform. Next, we'll study a way to customize the work with an entity, represented by a transaction. We will later see that it is also possible to create work with elements not associated to transactions. As we know, the specification to have a work with a particular transaction automatically implements a screen to show the list of elements, and also another screen to show the detailed information of a specific element. So, the first thing we can customize is the info shown to the user, and the way in which this info is shown. This means everything related to the user interface, that is, the layouts. We can also customize the order in which the information appears on the list, or the searches offered to the user for selecting the information to be recovered, as well as other internal filters for conditioning the information that will be displayed. And lastly, we can customize its behavior by adding or modifying events to perform certain actions. Let's start with the screens. The customizations possible will depend on each of them. If we're on the list node of the work with pattern corresponding to the property transaction, we'll see that it shows us the layout. We have a predetermined grid control, the one that implements the listing. This includes only a few of all the attributes in the transaction. With the toolbox, we can add or take attributes from that grid, as well as other controls. For instance, we can add the address, property address, and customize the properties in this control. The position of the label, for example. Here we see it on the left. But let's suppose we want it on top, as they usually appear in Android. Or that we don't want it to appear. The platform default value is a sort of wildcard, establishing that, at runtime, it'll be shown according to the standard of the platform selected. In the case of Android, it'll be shown on top, even if in the design screen we see it on the left. Now let's see it at runtime. F5. We can see that by the address is an icon to see it on a map. Because the address domain on which the attribute is based is associated to the corresponding semantics. So, in a way transparent to us, the program generated for the smart device includes the logic to use its native map. We can then see that the application generated is integrated with the native functionalities of the device. Now we want to modify the distribution of controls and the spaces between information. Note that the information on each property is presented in 2 rows and in 2 columns. That is to say, in a table inside the grid. The image of the property and its name appear on the first row and the address on the second row. If we want to make the column with the image a little wider, in the table properties, we'll modify the style of columns. By default, the first one takes up 64 dips, device-independent pixels, and the second one is extended to cover the entire width. What's a dip? It's a measuring unit that represents an abstraction based on the pixel. It allows scaling the screens to different sizes. The application generated then converts them into physical pixels according to the device's platform. The first column here has a fixed size of 64 dips. We may, on the other hand, want it to cover 30% of the width, and the second, the other 70%. If we take a look at the rows, we'll see that they are both the same size, but we can also modify this. We can see that both rows have the PD value, which stands for Platform Default. That is to say, the size of each row, as far as height goes, will be taken from the default value of the platform. The default value of Android phones is 64 dips. We can modify the value of each row by either setting the value in dips. For example, the first row will take 65 dips and the second 35. Or through a percentage relative to the height of the table. Here we will set the first row to take 65% of the height, and the second row 35%, with the height of the table configured through the height property, which by default takes the value Platform Default, though it may be changed to 100 dips, for example. We could also want the image to spread over the two rows. Now let's suppose that instead of viewing the list of real estate properties as a sequence of elements in a row, we want to see them differently, like in a gallery of front view images. So who will implement the list in GeneXus? The answer is the grid control will. Let's search among its properties, one that represents the way in which the data is presented. This one, the control type. When it has no assigned value, it represents the standard type of listing. But we can change that by choosing from among the specific user controls it offers for smart devices on this list. From these, let's select the Image Gallery user control. We have to configure the attribute containing the image used for the gallery. And if we want, we will use the attribute as the image title. As well as the one we'll be using as a subtitle. We can see that we may move along the gallery between thumbnail images as well as enlarged images. By tapping on the image of the property, we will see its details. The user controls adequate for the context will depend on the data we have on the entity. For example, to use the SD Maps user control that shows the list as points on a map, we will need an attribute for the real estate property of the data type geolocation domain, which stores the property's geographical latitude and longitude. We define it in the transaction structure. and we can see that it automatically assumes the geolocation domain. And at this point, we indicate that the attribute containing the geographical location is the one we have just created. Property geolocation. GeneXus will reorganize to add the new attribute to the table. And once the application is regenerated, we will have to assign the geographic location to the real estate properties that we've entered. Having done this, we see that when we execute the listing, and when we tap on one of the points shown, or another, and if we want to see full details of the property, when we tap, it shows us. The list screen continues to perform its functions, even when we've modified the way in which the info is displayed. For instance, we can do a search by address. Filter by neighborhood. Here we can see both properties of that neighborhood. Or insert a new real estate property. Here we see other examples of user controls for showing the data on the lists in a specific way. The developer may also create his or her own user controls. To do so, we recommend reading the documents available in our wiki. We have just customized the layout of the list of real estate properties. We also want to customize that of the detailed information on a specific property. For this, we have the Detail node, with the nested section, the General section. Now let's do some research into each aspect.